So in this video we're looking at shapes of molecules. Rather, we're looking at simple molecules. And what we know about simple molecules is they are covalently bonded. So covalent bonding. So just a recap of our understanding of covalent bonding. Let's use an example of methane. This is where carbon has 4 hydrogens. Okay, this is where GCSE chemistry comes very handy. And we're just going to do the dot and cross diagram of CH4 of methane. Key thing to note here then, and something that's really important to take note of. You've got a pair of electrons between carbon and hydrogen. Carbon is in group 4, shares 4 electrons with 4 different hydrogens. So we would say a covalent bond simply equals a shared pair of electrons between 2 atoms. Shared pair of electrons between 2 atoms. Okay. Now this is the key term here, shared pair of electrons. Just please remember this term. So a bond is a pair of electrons. So the shape of a molecule, so the shape is determined by the following. Is determined by the number of electron pairs around a central atom. Okay. Now, electron pairs are 2 types. You've got bonding pairs and lone pairs. So there are 2 types of electron pairs. So just to summarize what we've covered so far, a bond is a shared pair of electrons. Electron pairs are 2 types, bonding pairs, lone pairs. Now what's a bonding pair, what's a lone pair? I'll give you an example using using ammonia as an example. So nitrogen is in group 5, so it has 3 hydrogens bonded to it. So each nitrogen shares an electron with hydrogen. That leaves a pair of electrons spare. This spare pair of electrons we are going to call lone pair. It's not bonding with anything. This pair of electrons, this dot and cross, we're going to call this a bonding pair. So in other words, wherever you have a bond between 2 atoms, where each atom is sharing an electron each, that's a bonding pair. Where the pair of electrons is not bonded to anything, just as in ammonia, the one I'm just circling, that's my lone pair. So shape, therefore, is determined by the following. So we will say pairs of electrons or electron pairs repel. Because you've got 2 negative charges, they will repel. So the aim of a shape, or the aim of shape of a molecule, is to arrange electron pairs in such a way to minimize repulsion. That's the basic theory. And we will say lone pair to lone pair repulsion is the greatest. Bonding pair Co2 bonding pair repulsion is least. Okay, now you can pause the video here just to and go back to the video just to understand everything I've said so far. We're going to look at a few examples now in order to understand how we determine the shape. Okay, we are going to look at a few examples. I'm not going to go through every single shape that is required at A-level chemistry. The first one is, let's look at CH4. Carbon is in group 4. So carbon is in group 4. Carbon donates or shares 4 electrons. Carbon is my central atom in this molecule. The reason is central is because 4 hydrogens are bonded to it. It's on its own, in other words. Each hydrogen shares 1. So in total, we have 8 electrons in total. So there are 8 electrons involved in CH4, or the outer electrons are 8. Electrons go in pairs, so we have 4 electron pairs. Now let's decide, are they bonding pairs or lone pairs? Well, if you go back to the dot and cross diagram, then you know there are no spare electrons. So this is 4 bonding pairs. This bit you have to learn. 4 bonding pairs means it's tetrahedral. You must draw the shape in 3D. You can have a read of what the dotted and the wedge means. So there you are, and it's tetrahedral, and the bond angle, and the bond angle is between bonding pairs 109.5. This bit, what I've circled, you've just got to remember that. So any shape that has 4 bonding pairs, no lone pairs, it will always be tetrahedral. Now let's look at water. Oxygen is in group 6. So oxygen donates 6 electrons. There are 2 hydrogens. They donate an electron each, which is 2. In total, we've got 8 electrons. So total electrons is 8. That means 4 electron pairs. This time the shape is different. The reason is there are only 2 bonding pairs, because only 2 hydrogens are bonded. So 2 bonding pairs. So let's draw the shape. O, 2 bonding pairs. It has 2 lone pairs, 1 and 2. In total, there are still 4 electron pairs. There are 4 electron pairs. However, 2 bonding pairs, 2 lone pairs. So we will say the shape this time is the bond angle is 104.5, and the shape is V-shaped. You can call this angular, you can call this bent. The lone pairs reduce bond angle by 2.5 degrees. 4 electron pairs is same as methane. The only difference is methane is tetrahedral. So because it's tetrahedral, its bond angle is 109.5. Here we have 2 lone pairs. Each lone pair reduces by 2.5. That's 5 degrees in total. So the bond angle is 104.5 degrees. Another example. Now, oh yes, so the question will be why. All you need to say is because there are 2 bonding pairs, 2 lone pairs. Lone pairs repel much more than bonding pairs. Bond angle is reduced. Let's look at another example. Let's look at an ion, NH2-. This is an amide ion. Here now, nitrogen is in group 5, so nitrogen contributes 5 electrons. Hydrogens there are 2 of them. They contribute 2. So in total we've got 7 electrons. We can't have 3.5. Remember what minus sign means? Gain of an electron. So here we have 8 electrons, 4 electron pairs. Shape is same as water, NH2. Don't forget the square brackets, minus, and 2 lone pairs. Bond angle 104.5 degrees. The other shapes you need to know about, I'm just going to give you a list of shapes you need to know. BeCl2, this is linear. BF3, this is trigonal. Planar. CH4 we've done. PF5, this is trigonal bipyramidal. SF6, octahedral. And please note, linear 2 bonding pairs, trigonal planar 3 bonding pairs, trigonal bipyramidal 5 bonding pairs, SF6 6 bonding pairs. There will be other shapes of ions which you will come across, but this is the very basic understanding of shapes of molecules. If there are any questions, please ask. Thank you.